Okay, so before we start the class for today, okay, can you please switch on your camera for a while for me to record your presence? Just sekejap eh. Okay, please switch on your camera for those who are yet to switch on the camera. Okay, thank you very much for your kind cooperation. Okay, so now let me share my screen on the topic that we will cover for today. Okay, so the topic that we will be discussing about today will be on the use of GIS for spatial analysis, okay? Okay, so from previous lectures, okay, we have discussed about GIS in general, okay, and in fact, when you are doing the remote sensing data analysis in QGIS, we are in fact already in the GIS environment. It's just that you are utilizing some plugins that were developed specifically for the processing of remote sensing data through or from within the GIS or QGIS environment itself. Okay, so with the GIS software that we are using, which is the QGIS, everything is basically being integrated together in a GIS environment. Okay, that is actually the trend nowadays in the industry, the geospatial industry. If you look at the software used by Esri, which is ArcGIS, probably some of you are using ArcGIS, okay, for your project, okay, maybe for your final projects or for some other assignments. All right, so you can see the ArcGIS also is now integrating the remote sensing tools inside the GIS environment. Okay, previously everything was a bit separated before the current trend of integration. GIS and remote sensing software are normally separated and developed by different entities. Okay, but now the trend is more like there is an integration, and they are being combined together into one, what I call it, a platform. Okay, I think the main aim there is basically to provide the users with a one-stop center for everything related to geospatial, so they don't have to go here and there. Okay, so they just use one particular platform and everything is within that particular platform. All right, so having said that, in a QGIS, okay, in QGIS, if you want to do some spatial analysis, there are a lot of options that you can use, okay, in QGIS. Okay, so if you have got the data from remote sensing, maybe from multispectral radar or LiDAR, or you might also have the GPS data. Okay, so once you have got all this data being compiled together in a GIS environment, the next question is what you are going to do, okay, with the data that you have. Okay, so once you have got the data, all right, it might serve. I mean, the data can be used for variety of applications. Okay, probably you want to use it for visualization. Okay, to visualize your study area, okay, to get a better overview of what is going on in the area of interest, right? And also, other than that, one of the main reasons, okay, why we use a GIS is because we want to do spatial analysis, okay, not just spatial visualization. Okay, so spatial analysis will help you in making, or in, we call it, will help you in making decisions, okay, with regard to whatever applications that you are working on. Okay, so for today, specifically, we are going to look at the use of GIS, okay, and spatial analysis in order to help us to determine whether a particular area is suitable for development, or a particular area is suitable for what you call it, for developing certain infrastructures. Okay, let's say for example, you want to know whether which areas are suitable for school, okay, to locate schools, or to locate dump sites, or to be developed as a new residential area. So as engineers, or as town planners, or as probably administrators, okay, so you need this kind of information to help you in making decisions. Okay, so uh, even though, I mean, a lot of situations, people or the decision makers just make decisions based on their gut feeling. Okay, but uh, this is actually is not a proper way of deciding on whether an area is suitable for development or not. Okay, so because gut feeling is very subjective. Okay, so you need to have a much more systematic way of making a decision. All right, and a lot of factors need to be taken into considerations. Okay, before you can decide, okay, on a suitability of a particular area for development, for instance, because later on, whatever decisions that you are making, okay, will can be questions, okay, can be questioned by the public, okay, or can be questioned by the government, especially when there are uh, there are negative impacts, okay, from the development and so on, that are already taking place in a particular site, for instance. Okay, so there is, I mean, GIS or geospatial data can help us, okay, in making decisions. Okay, so today we are going to look at some of the things that we can do with geospatial data. Okay, for example, um, we can use certain analysis in GIS. Okay, for instance, a vector overlay analysis, a raster overlay analysis, spatial query, network analysis, predictive modeling, and so on, in order to help us in making decisions. Okay, and towards the end of the lecture, we are going also to discuss about the use of GIS and Python, okay, for programming, which will be covered in the future lectures, not for today. Okay, just hang on a second. Okay, so you have any questions so far?
No, Doctor.
Okay. Okay, so as I have already mentioned, GIS can be used for a variety of applications. Okay, so there are several, we call it users of GIS. Okay, firstly, uh, GIS is a database. Okay, GIS is a database where you compile all the data. Okay, you can actually compile not just geospatial data, you can also compile ancillary information. Okay, so you can actually relate a lot of information that are non-spatial with spatial data. That's the point of having a GIS. Okay, so let's say, for example, you have information about land ownership, okay, and the owners of the parcel of maybe you have a residential area with all the land parcels and so on, right? So you will have an information about the owners, okay, and the tenure of the land, whether it is a leasehold, a freehold, the types of the development, okay, whether it is a single story, double story, and so on. Okay, all this information can be tied together with spatial information. For example, the coordinates, the remote sensing images of the sites and so on. Everything can be compiled together in a GIS. Okay, so GIS is a database basically that can be used to compile spatial and non-spatial data together. And other than that, you can use GIS for visualizing, okay, your environment. Okay, so because if somebody is telling you that your house is located in, for example, in Sri Kembangan, for instance, near a school or things like that, but this is very subjective and it is very difficult for the others to imagine where your specific location is. So when you have a GIS, you can just show it to them with the spatial information, so they can view them. They can view the information either from a vertical standpoint or from the horizontal standpoint, and all this will help in a much more better understanding about what the information is all about. Okay, so that's another thing, is a visualization tool. And also one of the most important roles of GIS is basically to allow you to perform spatial analysis. Okay, so spatial analysis can take many forms. Okay, but the specific form or the specific function that we are going to discuss today is on the use of GIS for helping us to determine the suitability of a particular site for certain development, for instance. Okay, so when we talk about the use of GIS for site suitability, okay, from the literature or from the internet, you can actually find a lot of examples and applications. All right. For instance, just for the sake of showing you an example, okay, over here you can see um, there is a paper already being published about the use of GIS, specifically the use of QGIS, okay, for site suitability analysis for urban development. Okay, so how the engineers or the town planners use GIS to determine the site suitability. All right, how this can be done in a much more systematic and we call it a scientific way rather than using gut feeling or subjective criteria. Okay. Okay. What do you think about this? Based on your previous, maybe you have got some experience along the way, right? Um, you have been here for 4 years already, and you have done your industrial training. Have you come across any projects that will require the engineers to decide whether that particular area is suitable for a specific development? Have you come across this kind of problem? They say, for example, if you want to know which area is suitable for a new residential development, how the engineers or the planners decide where is the next most suitable area for development, for instance? How this is going to be done? Any ideas? Anybody can share your ideas or maybe your experience on this particular matter? Anyone?
Maybe by looking for the land use data.
Okay, very good, Harith. Okay, there is one of the factors by looking at the existing land use data. Yeah, that is also one of the criteria that can be taken into account. Okay, the suitability of a particular area, maybe a proximity of the potential site to existing land use. Yeah, for example, if you want to develop a residential area, of course, you want to avoid your next project to be next to a factory, for instance. That will not be appealing to a lot of buyers, for instance, isn't it? So potential buyers will be looking for much more serene area, okay, much more green areas, for instance, right? Okay, that's a very good, Harith. That can be one of the factors that can be taken into account. What else should be taken into account when you want to develop an area, for instance, for new residential development, for instance? Land use, existing land use, what else? Okay, anybody else that would like to share any ideas this morning?
I think during IDP or project, we check for the type of land.
Yeah, you have
The
done the capstone, right?
soil. Yes.
Yeah, so soil types, yeah, that is also a very important factor. Okay, the suitability of the soil, okay, for development, that is very crucial actually.
And also the characteristic of that place. Like the rainfall, something related to the rainfall, and
Yeah.
then um wind,
Okay,
stuff like that.
environmental factors you mean,
Yeah,
yeah?
environmental.
Yeah,
Yes.
environmental factors that could affect the what you call it, the yeah, I mean those things that can affect the comfort level, basically, right, of a particular site. What else? Apa lagi? Okay, there are actually a lot of factors. If you want to I call it if you want to think in detail, all right. So that when you present your proposal on why this area is suitable for development, you have the scientific I call it the scientific facts, okay, to support your proposal, okay, not just by maybe some politicians coming from that area and he just wants you to develop that area, not just because of this kind of factors, right? Um, we want our decision to be more scientifically sound, okay, and it's based on facts and figures rather than based on sentiments and emotions, right? So for this purpose, for instance, okay, for this particular paper that I'm showing you, okay, for example, for urban development suitability analysis, okay, for maybe an area, this for this example, it is in India, for example, that can be applicable anywhere else, right? So for this particular project, they use, for example, topographic information, okay. For example, they need to know the slope, right? They use also satellite images, the SRTM maps, okay, the radar. This is SRTM is a kind of radar map that can be used to, to generate slopes, DEM, and so on. Okay, and also proximity to existing land use. Okay, for example, like road proximity, land values, land valuation, and many other things, right? So once you have got all this information, this information can be compiled together in a GIS, let's say for example in QGIS, and you can, what is important is that you need to give a certain weightage to all these factors, right? Even though we might have maybe 10 factors, okay, that can be taken into account, but all these factors, they might have a difference, they might have a different level of importance, all right? So the weightage will be different for each of the criteria, all right? So, when we use a QGIS, for instance, we can assign the weightage, and this weightage will be, you will generate some kind of a formula, all right? You will generate some kind of formula that will combine all the factors and their weightage, and then for every single pixel in the what you call it, in the raster GIS data, you can assign the values, right? So once you combine the values for every single pixels, okay, in the process, you can generate a map showing, we call it the suitability level, okay? So we will do it later on, okay? We will have some hands-on with Mr. Yu Hao later. Okay, this is also another example, yeah? So this for this particular example, they are using QGIS, okay, for site stability, but for solid waste dumping site determination, okay? For instance, where we can locate, we call it a new solid waste dumping site, for instance, and what are the factors, okay, that should be taken into account for this particular application. So in this paper, for instance, you can see that there are also various factors that are being taken into account. Okay, for example, the land use, the land cover, the distance from road, lake, river. Okay, that is also very important depending on what application you are working on. If you are working on, let's say, for example, waste dumping site kind of determination, of course, the proximity to lake, to river, okay, to environmentally sensitive area will be of high importance, right? You don't want the waste to pollute an existing waterway, for instance, right? So that is very, very crucial. Okay, so that's why without a proper planning, or there are a lot of illegal plannings or illegal constructions going on in Malaysia, for example. This is one of the main problems that we have in our country. Okay, illegal construction of industrial areas, illegal factories, okay, illegal dump sites. There are so many problems of this kind in our country at the moment because there is no control from the authority, there is no monitoring. Okay, so without a proper planning, we are going to face a lot of problems later. Okay, this is what Malaysia is facing at the moment. All right, so it is very important, okay, for us to plan properly, and of course the engineers very important in this planning process, okay, in the construction process, and when you go out to the industry later on, you should, for example, you should advise, okay, you should be able to advise, okay, the authorities on what should be done, okay, in order to carry out a proper planning, okay. Okay, so in terms of the analysis, in terms of the spatial analysis that can be used for site stability determination, there are two types of analysis that can be carried out. The first one is called suitability analysis with vector data, right? This is the first type of suitability analysis. Okay, it is called suitability analysis with vector data. Okay, this one is a simpler type of suitability analysis. Yeah. Okay, this is a simpler type of suitability analysis because we are just using some basic operations in GIS, for example, buffering, clipping, intersections, and union, for instance. These are very simple. That is more suitable for binary kind of decision making, whether this area is suitable or not suitable, something like that. Okay, 0, 1, binary. Okay, but if you want to carry out a much more, we call it objective kind of decision making, normally we will carry out suitability analysis, okay, with raster data. Okay, this is something that is that is of a particular interest of what we want to do later on in our class. Okay, so you can see the difference between suitability analysis based on vector versus raster. Okay, for vector, normally it will involve operations like buffering, overlay, things like that, which is pretty simple. Okay, but for raster, normally we need to determine the weightage. We need to determine the weightage and develop a particular formula, right, to be used in the raster data suitability analysis later on. Okay. So this is an example of vector analysis. I'm not going to go very deep on this one because this is something that we are not going to do today. But just to let you know that the vector analysis is going to give you a binary answer, whether it is suitable or not suitable, okay? Something like that. And it will involve, for example, operations like buffering, union, intersecting, overlay, okay, in QGIS. You can see also a demonstration on how the vector-based suitability analysis is being carried out in QGIS. I'm giving you this particular link in YouTube. Okay, in this particular example, if you go and watch the YouTube later on, the example is working on determining the suitable site for new commercial zone determination based on certain criteria. For instance, the developer, we call it, determine that these are the criteria. Okay, these are the criteria that we need to fulfill. For example, the new commercial zone should be located within 1 kilometer of accessibility to existing road. It should be located at least 500 meters away from water bodies, 3-kilometer distance from railway stations, and so on. Okay, so you can go and look at this particular example on YouTube, okay, on how a simple vector analysis can be carried out, okay, to determine the suitability area. Okay, this is also another example. Okay, this is an example of how we can use vector analysis to find a suitable area for development with certain criteria. Okay, with certain criteria. This is a very basic, for example, a vector analysis. Okay, that was carried out by Department of Survey and Mapping. So they have a certain criteria and they can find the suitable sites for development. Okay. Actually, last year, we have an assignment on this vector analysis, but we are not going to do that for this year. We are going to just do a practical on raster analysis for site determination. Okay, so we are going to skip the vector-based analysis. Okay, so you have any questions so far?
Not at all.
Yuhao, anything you'd like to share with the students regarding vector analysis? But the one that we are doing today is raster analysis, right, Yuhao?
Yes, doctor.
Okay.
Yeah. So they are another type of vector-based analysis that we use the overlay analysis in the format of the vector like in the shapefile. But today we will use the type of images in the form of the raster in the TIFF format. So we will look for this raster overlay analysis later.
Okay, all right. Thank you, Yuhao. Okay, so actually in the QGIS, you have several options on doing this particular work. Okay, so you can use the manual operations. Okay, we can use normal operations like what we are doing normally with GIS analysis in any GIS environment. What is also interesting in QGIS is that not just QGIS, if you work on ArcGIS also, you can create something like what we call it as a graphical modeler. Okay, graphical modeler is something very interesting because the graphical modeler will allow you to, to have a model like this one. Okay, what is good about this graphical modeler? In fact, you can do anything, okay? As long as the tools are available in QGIS, you can use the graphical modeler to create a model like this one. Okay, what is good about graphical modeler is that if you want to do a presentation, okay, to a stakeholder or to anyone with regard, with regard to what you are doing. Okay, let's say for example, in this case here, this graphical modeler is showing us, okay, the steps, okay, that you have taken, okay, the steps that you have taken in your site stability analysis, for instance, yeah, right? So over here, in the graphical modeler, probably you are also familiar with the graphical modeler in QGIS, right? Okay. So in the graphical modeler, okay, straight away you can see what are the steps involved, okay, in the process. Okay, for instance, you start with the determination of the factors. Okay, for example, if I want to determine whether that particular area, which area is suitable for development, for instance, if let's say, for example, I use factors like road, building, transportation, and vegetation, for instance, soil, okay, and then I can generate the rules, okay, and combining the rules through intersections, union, and so on, okay, and come up with a final output based on the rules that I have set up. Okay, so probably at the moment, if you are yet to use this particular tool, maybe it is very difficult for you to understand what is going on, but you can probably try this later as well. Okay, so that is a graphical modeler. The modeler can be used with the vector analysis or with the raster analysis. Okay, and what is important for us today is actually how we can use the raster analysis, okay, in the determination of the suitability. Okay, so the main difference between the raster and the vector analysis is that for raster analysis, you are not just determining the binary decisions, okay, not just suitable or not suitable. Actually, you can give a ranking, okay, a ranking, or you can give a particular scale, okay, to your decision. Okay, so it's like you have a 0 to 1 scale of suitability. For instance, number 1 is the most suitable, 0 is the not suitable at all. All right, so you have the decision in between. Okay, so you can have the level of what you call it, the gradual score between 0 to 1 in your determination. It's not just 0 and 1, but you have 0, 0.5, 0.4, and so on in terms of the suitability. So you will have better what you call it, objectivity, okay, in the determination of your decision. Okay, so this is what we are going to do. This is an example of one of the one of the things that people have done by using raster analysis. For instance, we want to use a GIS to determine the flood hazard area. Okay, so maybe the final map over there is too small for you to see, but you can see that there are 4 levels of hazard, okay, that can be determined. Okay, for example, from low, moderate to high to very high. So which area is having a low hazard, which area is having very high hazard to flood. Okay, so as engineers, for example, you don't want to determine whether this area is dangerous, not dangerous. Okay, what is more important is you want to know how the level of the danger of that particular area to flood, for example, so that you can do a proper actions in terms of the planning, in terms of the evacuation plans, okay, and so on. Okay, the level of, that one will basically determine the level of, what you call it, priority, okay, that can be taken into account by the authorities and so on in events of disaster. For example, which area will be, which area you should focus more in terms of the resources, okay, and also the emergency, what you call it, actions, which area should be given more priority. So not just by telling that it is dangerous, it is not dangerous. So that one is very difficult for you to, to allocate the proper attention to that particular area in an event of disaster, right? So in this particular example, for instance, we want to know which area is having the level of hazard for that particular area. So what we need, okay, in order to come up with a map of the hazard probability or the hazard risks and so on. So for instance, here we need to use, for example, satellite image data. From the satellite image data, you will be able to determine the elevations and also the land use and the land cover, okay, things like that. And there are also some data that need to be acquired from a much more detailed site investigations, for instance, from soil tests. Okay, you need to know, for example, the soil type, the surface roughness, and so on. And all these factors, okay, will be compiled together in a GIS. Okay, so for example, at the end of the day, you will have a 1, 2, 3, 4, 5, 6, 7, or you have like 7 factors. Okay, runoff, slope, okay, drainage factors, distance to main channel, land use, space roughness, and also soil type. Okay, so over here you can see how this information coming from a variety of sources can be compiled together in a GIS environment. Okay, and the next one is you need to determine what is the level of importance of every single factor that can affect the hazard level of that particular area. Okay, so after certain analysis, for example, in this particular case, this guy is using a process called analytical hierarchy process. This is called AHP to determine the relative importance for each of the factor. Okay, so the factors, for example, there are different factors, okay, and also different weightage for every of the factor, and all this can be combined together in a formula in the GIS, and from there, you finally will come up with a GIS-based flood hazard map. Okay, so this is an example of how this can be achieved through a GIS environment. Okay, this is also another example. Okay, this is for wildlife application. For example, you want to know which land or which area is suitable for relocation of wildlife, for example, for black bass. Okay, for this particular area. So what are the factors that can affect the determination of determination? I mean, if you want to determine the habitat, okay, the habitat for wildlife, for instance, okay, if you want to know the suitable habitat for wildlife, what are the factors? Okay, for example, proximity to trails, okay, the vegetation types is very important as a source of food, proximity to roads, slope, and also proximity to streams, okay, as a source of water. Okay, so by combining these factors together through a weighted overlay, okay, through certain weightage, you can finally determine the areas that are the most suitable, the less suitable, and also the least suitable for a particular wildlife, for instance, right? Okay, this is an example for ski resort development. For example, what are the factors that need to be taken into account if you want to develop a new ski resort? Okay, so for this particular example, okay, the planners use factors related to land cover, access, snow precipitation, land ownership, elevations, aspect and slope, for instance, okay, to come up with the most suitable area for ski resort development, for instance. So similarly, we can also apply this particular methodology for other types of development. Okay, for example, residential development, for maybe infrastructure development, okay, for industrial area development, and so on. The same methodology can be adopted, okay, for different types of applications. Okay. Okay, so what are the general steps, okay, to perform weighted overlay analysis? Okay, firstly, of course, you need to define what is the problem, what you want to determine, okay, and then you need to break the problem into submodels, or you need to determine what are the factors. Okay, you need to determine what are the factors, okay, for that particular application, and then determine the significance, all right, and then put the weightage to the layers, and finally analyze them together in a GIS. Okay, so I'm giving you also another example. I think this is the example that Mr. Yuhao will be using today. Okay, this is another example of the weighted overlay analysis for, I mean, suitability for what application is this? Right, I'm just taking it from another example, right? Okay, this is how, for example, you generate the formula in a QGIS or in ArcGIS, doesn't matter, the same thing, right? So you will generate a formula based on the weightage that you have determined before. For example, slopes, that is the weightage and so on. So the total, we call it the total sum of all the weightage should be 1 or should be 100, for instance, okay? Right? So finally, you come up with a final area where you can, you know, determine the suitability and so on. But keep in mind that the most challenging part, okay, the most challenging part for you in this particular kind of analysis is actually during the process of determining the weightage. Okay, that is actually the most challenging, or can be sometimes be a bit subjective. Okay, you have to know what are the proper ways of determining the weightage. Okay, so some people, they use, for example, questionnaire. Okay, they use, for example, they use interviews with experts in order to determine the weightage. For example, they will go and interview the engineers, the geologists, okay, the, we call it the planners and so on, okay, to seek or to get their opinions on the weightage. Okay, that's another thing. Another way is the weightage also can be determined through scientific experimentations. Okay, and in some cases also the weightage can be determined through the use of AI methods. Okay, to avoid the subjectivity of the weightage. Okay, because if you go and interview in order to get the weightage, sometimes this also can be subjected to some kind of bias and subjectivity of the experts. Okay. Okay, this is just an example, suitability map for best site of new school, for example, right? Areas for development. Okay, these are all the examples. Okay, landslide, susceptibility, zonation. Okay, this is this kind of suitability also can be used to determine areas, okay, that are susceptible to natural hazards like landslides, like floods, and things like that. Okay, but you need to, I mean, the challenge here is, firstly, you need to determine what are the parameters, what are the factors. Okay, whether the factors that you have taken into account are sufficient or not, that's another thing. And the second thing is that the weightage that you have been given, okay, to the layers or to the parameters, whether they are really accurate or not. Okay, so these are the things that you need to be careful about, okay, when you perform this kind of analysis, right? AHP is one of the most popular ways of determining the weightage, but other than AHP, there are also other things, okay, that can be used to determine the weightage. Okay, so I'm not going to discuss about the network analysis yet at this point, because this is something that I'm not going to discuss for today. Okay, because for today, our main aim is basically to carry out the weighted overlay analysis by using a raster method to determine the site suitability. Okay, for the others, it's either you can just go through. Okay, this I'm just giving you some other things that can be done in a GIS environment, like network analysis, okay, to find the shortest path or to find the suitable, what you call it, the most optimal route for delivery and so on. Probably for those who are working with Grab or Foodpanda, they will be interested with this kind of applications. Okay, spatial query, just a standard one. Okay, predictive analytics is also something. I mean, we can sort of look at the site stability analysis by using weighted overlay as a kind of predictive analytics as well. Okay, I mean, because we are predicting, okay, the suitability and so on. This is also a kind of prediction. Another way of doing a predictive analytics in GIS is by analyzing historical data. Okay, this is a standard way of, this is also an alternative of determining, for example, we call it natural hazards. A lot of studies use, for example, machine learning to determine susceptibility of certain areas to natural hazards. Okay, so it's quite similar to how we do it in the site stability analysis, but the difference is that, okay, in this particular predictive analytics, they need to use a lot of historical records. Okay, they need to use a lot of historical records in order to determine the landslide susceptibility or flood susceptibility and so on. Okay, but this for this particular method, it is entirely based on machine learning and AI without the need for subjective opinions, okay, from experts and so on. They just entirely based on historical data. Okay, this is something that we can also have a look later on, but not today. Okay, Python we're going to discuss later. Okay, in the coming weeks. Okay, so for what I have presented today, we can see that GIS, I think everybody knows that GIS is a very powerful tool, okay, to help us in decision making. It's just a matter whether how we can use GIS. That's the main thing. How we can use the tool that we have in our disposal, okay, to help us in making decision. And GIS can be used by anyone, basically. Okay, not just for engineers, not just for surveyors. Anyone is using GIS nowadays. Okay, you can see GIS also being used for business decisions, okay, for financial analysis, a lot of things GIS can be useful for, okay. So what you are doing for today is a practical to determine weighted overlay analysis for site stability, Okay, this is what you're going to do for the practical sessions. So you have any questions? I have to go a little bit fast today because I need to attend an event after this. So before I pass this to you, how? Okay, you have any questions?
I think no, Doctor.
Okay, just now I've got a message, maybe from Haris, right? This morning.
What? I didn't send any message, Doctor.
Siapa hantar saya message tadi Sekejap sekejap just wait. Oh, Danish, yeah. So Danish, you are here?
Yes, Doctor.
Okay, I got your message this morning, right? So for your test 2, you're saying that you are going to use road network analysis.
Yes.
Okay. So from where you got the data?
The road network, I think I can get from the internet.
Okay. How about the, for example, the flood map?
The map is actually it is already obtained from my
okay.
FYP.
Oh, okay, that's good.
Mm-hmm.
Okay, so I think this is a very good topic. You can use QGIS, okay, to perform this kind of analysis. So please proceed, yeah? That's very
Okay.
good.
Thank you, Doctor.
Okay, that's nice. Okay, and then, I mean, all the other groups, you have determined the topic. Who was in charge of this particular thing from last week? Siapa in charge last week? Who gave me they call it the main document about the topics and so on? Siapa, who gave it?
Me, Dr.
Nurin,
Nuri. Yes.
So all the groups have determined the topics.
I'm not sure. I think yes.
Okay, so for the other groups, please update. Okay, maybe there are some changes and so on to your topic. Please update this information to Nurin. Okay, and Nurin, by the end of today, please send me the finalized topics. Yeah.
All right, Doctor.
Okay, good. What else? Okay, now we are already, this week is already week week 8 or 7, yeah? Week 8 or week 7 this week?
8, Doctor.
Oh, okay. So week 8 already. Okay, so it's already week 8. After this, week 9, all right? Okay, so we can take a break for 5 minutes. And after the break, I will pass this particular session to you, Hao, okay, to continue with the hands-on. Okay, just to remind you, for the practical parts, we are going to have 2 practicals. Will be 2 practicals. The first practical, I think you have already seen this on Putra Blast. Yeah, you have got this, right? in Putra Blast. Okay, so from the Putra Blast, you can see for the practical assignment 1, it is about the classification assignment, okay, using the hyperspectral data. And then later on, I will also be giving you the practical assignment 2, which is related to, I will share this later on Putra Blast. So I don't think you have to do so much in this particular course. So it is quite relaxing, isn't it? Okay, so this will be the practical assignment 2. Roughly, you can see that, I believe. Okay, for this practical assignment 2, you need to go around the Faculty of Engineering, okay? Okay, you need to go around the Faculty of Engineering and collect some data, okay? Because in this particular practical assignment, you need to create a simple GIS database and map, okay, for the Faculty of Engineering. I want you to do some sort of outdoor practical, you know, some data collection, okay, to get you the proper feeling of geospatial data collection. Okay, so you can use your handphones, okay, you can use, if you need to use, for example, GPS receiver, but I think if you're using handphones will be sufficient. Furthermore, if you are using the handphones, you can download some interesting GIS packages. I think Yuhao last time I shared with you the locus map, right, Yuhao? There are also other things like QField, okay, that can be used for data collection. So you can compile a very simple geospatial data around the faculty. Okay, you compile the GPS based data, you can use the satellite data, you can use the existing GIS vector, and you can create a simple GIS for the faculty. Okay, you can be more creative about this. You can create like an interactive GIS database, or you can create a web GIS that can be accessed by everyone. So please think about how to make it something more interesting, not just a static GIS for display and things like that. Okay. So this is your second practical that I will be sharing with you later on Putra Blast anyway. Okay, before I stop this particular part from my side, can you please switch on your camera for a while, because some of you may become a bit later. Can you switch on your camera just for a while for me to capture your presence? Okay, because after this I will be passing this to you how to continue. All right. Okay, thank you very much. Sorry, wait. All right, thank you very much. Okay, so don't forget to sign your attendance as well in the form with the form given to you. All right, so we take a break for like 5 minutes, and after this, Yuhao will continue with the practical side. Please excuse me because I have to attend another thing. All right, but you please proceed with Mr. Yuhao, okay?
Okay, then.
Okay, so thank you. I'll see you next week. If I have time, I will come back to this class. If I got the opportunity to come back, I'll come back to this class. But anyway, thank you very much, and I'll pass this to you, Hao.
Thank you.
Okay. Have a good weekend. So you have you got the materials ready for the students?
Yeah, doctor.
Okay, so we'll take a break 5 minutes. After this, you can continue, yeah, Yuhao?
Okay, sure.
All right, thank you, Yuhao.
You're welcome. We will start our practical sections at 10:21. Okay, I have good morning. I have shared my slide. Can you guys see my slide?
Yes.
Okay, great. Okay, let's begin with our practical sections today. Today we will use the GIS tools to do the suitable analysis for the site developments. So let me just briefly recap uh, the previous lectures. Why we need to conduct suitability analysis for site developments, because due to the population's growth and urbanization spur, it is better to find out site suitability for example, city developments, and determinations of appropriate site locations for the urban development is crucial. So site suitability approach can help to move toward the better urban growth locations, and also the approach allocate different weight and criteria. GIS is an efficient tool to help the decision maker and town planner to analyze the suitable site locations in the proposal. So before I proceed to the next one, uh, we can briefly think about what is the criteria to do the site suitability site to do the selections or the suitability analysis for these site developments. Perhaps one of the criteria is we need to develop or find the appropriate site locations that near to the urban and away from the protected regions such as forests or agricultural lands or the river. So we can think about, at this sense, if we provide this criteria, we try to avoid to develop in uh, uh, to develop in an area that near to that uh, the area that full with the biodiversity. So at this sense, environmental sustainability can be preserved. So these are the criteria we will be using today. So first, our criteria is we will be using the road data. So we will key in our criteria that will need to find the locations that near to the road and away from the water bodies. Water bodies can be river or lake or the sea, and we will also provide the criteria that uh, avoid to select the regions within protected regions such as forests, agricultural lands, and so on. So today the data that we will be used is in the form of the shapefile from one of the states in India. So we will be using 5 files in the form of shapefile, which are boundary, protected regions, roads, water polygons, and also water polylines. Okay, without further ado, we can I will demonstrate straight away using this file. So as we can see, I have displayed or imported the shapefile into the QGIS interface. So now to do the site suitability analysis, we need to run some of the procedure in our QGIS. So the procedure can be pre-processing. For example, we we need to convert our we need to convert our shape file into the raster file. So from the shape file into the TIFF file. So this is quite can consider under data wrangling, and also later we need to do some of the data pre-processing. So when we do the overlay analysis for the suitability, so it will be correct and not to be wrong. So for the first step, as we can see that this data is in the form of shapefile, so we need to convert them into the raster format. So usually the raster format is in the form of TIFF file, PNG, and so on. But in the QGIS, we will convert into the TIFF format. So to convert the vector format into the raster format, we need to go to the raster and click the conversions, and we can see the rasterize here, vector to raster. So we just need to click that. So for the input layer, we put rows. So so as we refer from here, for the fixed value, there are some of the setting we need to adjust later. So and output raster size unit, we need to put georeference unit. So because we need to align with our coordinate projections. And also for the height and width resolutions, we can put 15. So our output extent, we can key in our output extent that have the same output extent with the boundary. So you can look at here later on the handout. And lastly, for this, assign a specified no data value to output bands. Actually, we no need to set for this, because if we put 0.00 later, the raster value for this 0.00 will automatically convert to the no data value. So we just put not set. And now we can save our output. The rasterized output for the road. Okay. So make sure all the setting is correct. And then we click run. I will share this data later in the form of Googling. So it would take some moment to process. Okay, let's just see the product output. I think it has produced. Okay. Okay, so this is the output. It is in the form of 0 and 1. Meaning 1 is represent there's a road, 0 is non-road. So we need to do the same process for the other file also. So to make it easier, so we can just do some call, some kind of the run some kind of the method called execute batch processing. So by that we can save some time. Because we no need to process them one by one. So in the processing toolbox, if we can see the rasterize here, we can just right click and click the execute as batch process. Okay, so for this batch processing, we need to count how many files we want to process. So 4 of them. The remaining one is 4 of them. Okay, so boundary, protected regions, water polygon, and water polyline. Okay, so for this vote, before I proceed to the next, I think you guys know that for this water polyline, it has the attribute with the informations about the water informations, such as about the water bodies, such as rivers, streams, and so on. You can see, and it also have the name of the river. So this is this has been stored in the GIS database, right? So that is quite important. Once this is our data, so to do the suitability analysis, the data is important. So what kind of data we need to provide for this site developments? So it can be the relevant data, such as the water bodies, protected region, and other factors as well. For example, soil, as one of the students has mentioned just now, Noreen, I think. So soil, the environmental factor, it also can be it can be this data. So the more data, I think it is better, but it needs to be relevant to this site, to these purposes. So every analysis is special. So depending on our purposes. So I display the information about the water polygon. So we can see this also the information on the water. So basically, both of them is related to the water body, and this the road. The informations you can see bridge, tunnel. So this is quite an important information for us to do the suitability analysis. So this is the first and the most important one, as we are using the correct data. Okay, so okay, after all, I will proceed with this batch processing. So in order to save our times, we can process it parallelly. Okay, so till we will blank this place. So this is 1.0. X value. Output your output raster size unit. We will put your reference unit and the resolutions for this width and horizontal is 15. So output extend is boundary. So when we click fill down, it will automatically arrange the same for the rest. Now we can save our output. Okay, so this is for boundary. Okay, so in this autofill setting, we need to choose fill with parameter values and input layer. Because we are providing the parameter here, this consider the parameter. So later on, they will process according to this parameter value. Okay, let's first recheck. Okay, after that, we can run the process. It would take some moment to process. just a moment, because as you can see from the bottom, it is running with percentage. Okay. I think the process is finished. Let me check. Okay. Just a moment. Okay, I think. Let me check on that. Because the file is a little bit large, so we need to take some memory to run it. This is correct. It is also correct. Lastly is the boundary. We need to import the boundary. Okay. And for this, for the shapefile, we can remove the layer shapefile layer first. So, okay, so this is our rasterized product. So now we also need to go into the next pre-processing. The next pre-processing is to merge water polygon and also water also the polyline. So in order to merge them, we need to use raster calculator to merge them. So in the raster calculator, we will key in some of the raster calculator expressions, or we can also say it as some calculations equations. So this is the one you want to merge them together. So without further ado, we go to raster and raster calculator, and we would like to merge the water informations together by merging the water polygon and also water polyline. So we need to also provide the to save the output layer. Okay, so water bodies. Then after that, we click OK. So for the output format, it is saved in the form of the geotiff. So after that, it is ready and we can click OK. It will also take some moment, but this time is faster than previous one. Because now we want to gather the water, the informations related to the water together before we can do further suitability analysis. So these are some of the pre-processing steps that need to be done in the QGIS software or any QGIS or any GIS software. Because it would take some time, because you can see from the size it is big. The memory size is big.